Hey everybody, today we're going to factor trinomials. Tri we know means three. We can see that each of these math expressions have three parts to them. They've got an x squared, they've got some x's, and then they've got a number, a constant at the end. Now this video is going to go through two easier problems, two medium problems, and two difficult problems. So if you already know how to factor these basic ones, just jump to the end of the video and take a look at the more difficult ones, where we deal with things like 2x squared and 3x squared and 6x squared, and I also have negatives. But otherwise, let's go ahead and get started on factoring trinomials with some basic problems. First, what does it mean to factor? Well, to factor the number 12 is to find the things that multiply, right? 1 times 12, 2 times 6, 3 times 4. When we're factoring something like x squared, you could do 1 times x squared, you could do x times x, right? What we're really trying to do is, anytime we have x squared, there's two possible answers. So if we can break the x squared down into two separate x's, it will help us find what those answers are. So that's what we're really trying to do with factoring, is break apart those x's. We're going to break apart those numbers. So we're going to go ahead, and I like to use the generic rectangle model, the area model, the box method, whatever you want to call it. You put your x squared in one corner. Doesn't matter what corner. It basically just represents that you have like a tile on the floor, right? Something with some length and some width. It's the same on all sides, right? Now, when I have 7 x's, these could fit into some different spots around here. For example, I could fit some tiles like this. I could fit some tiles like this. So those would be x's, where they're the same length as that x squared. And then the 12 would be like these little 1 unit spots. 1, 1, 1, 1, 1, 1, 1 in each of those. So that's basically what I'm setting up with this. So as you can see, on the side of x squareds are some amount of x's and some amount of x's. So the only spot for the numbers to go, the constant to go, is in the bottom right. So now that I've explained that, we're going to go ahead and put that 12 in the bottom corner. Let's go ahead and take a look at those factors of 12 again. 1 times 12, 2 times 6, 3 times 4. We already got our x squared, and we know that that is x times x. But there's lots of options for 12. So I've written down all my options for 12, but which of them are going to combine to get 7x? If I put 3x in this corner and 4x in that corner, it doesn't matter which one, I now have 7x. That wouldn't have been the case if I did 1 and 12. That would have got me 13 x's, and that would not have worked. 2 and 6 would have got me 8 x's. That would not have worked. But 3 x's and 4 x's gives me the 7 x's that I have up in my trinomial. So I haven't really factored it yet. I've just written it differently. I still have x squared. I still have 7x. It's just on that little diagonal. And I still have the 12. Now let's go ahead and factor. X times x is the x squared in the corner. X times what gets me over to 4x? Well, that's a 4. And how do I take that 4 and get down to 12? That would be a 4 times 3. So my factors are x plus 4 on the one side times x plus 3 on the other side. And I can check my answer thinking x times x. Oh, that gives me the x squared that I have in the boxes and also the x squared that I have in the original. X times 3 is 3x that I have in the boxes. Not quite what I have up in the original problem yet. 4 times x is 4x, what I have in the boxes. Ooh, now 3x and 4x gives me that 7x. So now I've got that. And then 3 times 4 is 12. 4 times 3 is 12. So I have the same problem. Now it's just easier to find what my x's are. So that's all we're doing with factoring, but hopefully that's an in-depth, lengthy description. And now I'm definitely going to go faster on the other problems. Cool. I'm going to go ahead and set up the generic rectangle, set up the boxes. I can pick x squared to be in any corner that I want, but the number has to go catty-corner, has to go diagonal from it, right? Because I know that there's going to be some x's here and some x's here, so the 12 can only go in that other corner. Let's go ahead and factor 12. Well, we already did on the last problem. 1 and 12 doesn't get me to 8. 2 and 6 does get me to 8. And 3 and 4, well, that was the last problem. So if I add 2 x's and 6 x's, now I can check off my 8 x's. I haven't factored yet. Factoring is what times what. So x times x gives me the x squared. 2 times the x gets me the 2x. 6 times the x gives me the 6x. And then 2 times 6 gets me that 12. So factoring is finding like the length times the width, the base times the height. And now I have factored. That's my final answer. That would be my final answer on the previous one. Cool. Now we have some numbers out front. This is different. So if you fast forward that video, you might want to slow down and watch what we're doing on these problems. So in the black problem, we now have 2x squared. Again, it doesn't matter which corner that you put it in, as long as the 12 goes on the diagonal or caddy corner from it. Now we have 2 times 12 for our factors. Remember, factoring is finding the things that multiply. So I'm going to factor 24. And you're like, what? Why? I thought we were just factoring 12. Well, let's go ahead and factor 12 real quick. 1 times 12. That doesn't combine to 25. 2 times 6. That doesn't combine to 25. 3 times 4. That doesn't combine to 25. So what's missing? Well, what was missing was that 2 out front. Something's getting doubled in the problem. So when you set up that diagonal, it's key to multiply them. Think about factoring as simply just multiplying. So 2 times 12 is 24, and 24 is the number that we're going to factor. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Do you see the combo that gets us 25? I do. 1x and 24x gets me 25x. Now the trickier part is that the x squared is x times x, but now you have to decide, where does the 2 go? 2 does not go into 1 unless you want to use decimals. 2 does go into 24. How many times does it go into 24? 12 times. 12, how does that get into 12? Well, just 1 time. So you can see that we have 1x if we combine that corner. 1 times 12, I think I deleted that. 1 times 12 is 12. I'm doing too much erasing. And then we've got our 2x squared in our final corner. So our answer is base times height. X with a positive 12 times 2x with a positive 1. And that is factoring. Cool, on the blue one. Similar numbers I'm using. Hopefully that helps you discover some patterns in the video. 2x squared in any corner, 12 in the other. Go across the diagonal. We're actually looking at 24. Remember, we just did that list over here. 1 and 24 worked for the last one. That doesn't get us 11 though. 2 and 12, yeah, that's 14. 3 and 8, there we go. That gets us 11. So 3x and 8x gets me 11x. Now let's go ahead and factor. X squared is x times x. Where does the 2 go into? 2 doesn't go into 3, but 2 goes into the 8 4 times. 4 goes into the 12 3 times. And then we can see that 3 and that x matching up for the last spot. So base times height, you can do height times base. I'll do 2x plus 3 times x plus 4. Doesn't matter which order I go in. And our last one, we've got some 2's and 6's out front, but now we also have some negatives. So let's go ahead and pay attention. Again, especially if you fast forward to the video to look at the tricky ones. We've got 2x squared. We now have a negative 3. 2 times negative 3 means we're going to be focusing on negative 6. 1 times 6 could be a negative 1 or a negative 6. So we're going to be like double the length here. 2 times 3 gets me to 6, but it could be a negative 2 or it could be a negative 3. We are trying to find the combination that gets us negative 1x. Well, that first one would give me 5x if I combined. This one would give me negative 5x if I combined. That one will give me 1x, which is close. This is the combo that gets me negative 1x. So if I had 2x minus 3x, that would be negative 1x. Awesome. Let's go ahead and factor. X squared is x times x. Where does the 2 go? Hopefully you see that 2 goes into 2 one time. 1 times negative 3. And our factoring works out. What's our base? Times what's our height. And those are our factors. Cool. On our next one, we end with the most difficult one. So stay with me here if this is new to you or you're not sure what to do. We got 6x squared. Put in any corner that you want. Put that negative 3 in the other corner. Remember, we're factoring, which is finding the multiples. So 6 times 6 multiplied by negative 3 is negative 18. That could be a 1 and an 18, where either the 1 is negative or the 18 is negative. That could be a 2 and a 9, where either the 2 is negative or the 9 is negative. That could be a 3 and a 6, where either the 3 is negative or the 6 is negative. Which combination gets me to 7x? The first is 17, that's negative 17. Right there is going to get me 7x. If I do 9x, then minus 2x, and I could switch up the boxes, it doesn't matter. I'll show you that. I could switch it up and I'll still be able to do the problem. Negative 2x and 9x, I'm still going to be able to factor this. X squared is x times x. What does 6 go into? 6 doesn't go into 9 unless I'm using a decimal. 6 doesn't go into 2 unless I'm using a decimal. So factor it even smaller. What goes into 6 and 9? 3 is a factor. So watch what happens when I factor a 3 out. 3 times 2 will get me that 6. 3 times 3 will get me that 9. And if I use the 2, 2 times a negative 1 will get me negative 2. And then 3 times a negative 1 will get me negative 3. My factors, remember, are base times height or length times width. So my base is 2x with a positive 3. And my height is 3x with a negative 1. And there is factoring trinomials. Hopefully that helps you to factor trinomials. We did 2 basics with all positives and x squareds. Then we did some x squareds where we had a number out front. So we were multiplying that by any number out front. And then we did some x squareds where we also had negatives. So we did positive and negative off of those problems. Hopefully that helps. Let me know if you got any questions.